So I thought I'd give you a summary of the project. So my friend from church went across to Zambia and saw this structure that was being built. He touched it and it wobbled. And essentially it's a church building that's being constructed it's being constructed of scaffolding tubes, and they're being welded together at the joints. Yep. So I've got dimensions and things, and what I found for the wind loading that I just was talking about was, when I had a quick look at the wind load, it looks like I've got a wind load of 4.3 kilonewtons per meter squared, and that's because of the altitude at where it is in Zambia. So it's 1,300 meters above sea level. I've taken like gale force. Well, I think it's gale force winds, 30 miles per hour. 30 meters per second. And then gone through the calculations like I normally do. And because of the altitude, the wind acting on it it appears to be quite a lot. But I know that's applying. I'm not sure how to apply if there's any difference applying wind load in Africa. It is about 900 kilometers away from the sea, and I have taken that into account. But in the chart for country terrain or wind terrain, in the Eurocode, it basically gives for country terrain and wind terrain, it basically gives a like the maximum kind of like limit is, like the reduction is 100 kilometers away from the sea. And this is 900, so there could be some reduction in that, but it is at a very high altitude of 1,300 meters above sea level as well. So so this is the structure, and what I have basically been thinking about proposing is putting in cross bracing at various locations to stop any sway. But it just appears that this has been done without a design, and so it's just on site. They are happy to tie the structure down, so they're going to put like a tent fabric over it, and they're happy to tie the structure down using ratchet straps, and either putting concrete in the ground, or what I thought about suggesting was ton sacks, embedding them in the ground and then filling them with soil, compacted soil, and then tying it back to hold it down from uplift and from sliding. But then I'm just thinking about these scaffolding members, whether they have capacity. So I put this into a robot, and just under the self weight, there's only one central column in the structure, and so in between the central column, where not at the end bays have this horizontal tying the roof together, but mid span they've only got these little horizontal members, mid in the building, and then they only have one vertical column in the center, and so just under self weight it was bowing by 25 mil here, and this was pushing out here. So if we were to add on, if I was to add on, let's say rain kind of building up between the sheeting, between the tent sheet, and self weight from the wind acting vertically, then the structure may not be suitable. And I'm not so sure about the welds as well, whether what kind of welds are being so there's a lot of Yeah, I actually just, yeah, I just thought, well, I just got asked a question, and so I just thought if there's any way I can help, because it's in Africa, and it's a church building. It was a little, like, and because it was a friend from church, I went on the mission trip to this area, and then noticed it was wobbly. I just thought, yeah, maybe there's some way I could. So I've already suggested the bracing, and I'm just trying to think about next suggestions, if any. But yeah, any thoughts would be welcome.